From ContainerDays Hamburg, this video is proudly presented by Dux IT.
13 Kubernetes hacks you didn't know you needed. By the end of the session, we'll try to, I don't have a poll, but we'll do a raise of hands, maybe how many of you did know some of them. So that would be a good. So yeah, I'm head of DevRel at vCluster. So we changed company branding, and I got a promotion as well. So it's something that was a bit of a change, and you can connect with me. Okay, we'll start because there are 13, so there are a lot of slides to cover, some demos as well. So the first one is Kubernetes without kubelet. What happens is that on your laptop, on your machine, sometimes you need hundreds of nodes of testing. You want to scale that, and scaling takes a lot of time in Kubernetes when you want to attach nodes. This gives you the fake cluster, the fake set of nodes. It's without kubelet. There isn't actually node which is there, but on your machines, like on this particular laptop, I will be able to create 100 nodes in a few seconds, and you'll get that gist of, okay, you have those 100 nodes. So it has two things, like obviously fake nodes, pods, no cloud cost, perfect for testing your autoscaler, schedulers, queues, and you can instantly scale that. So it has KWOK, which is the cornerstone of the project, and then KWOK CUTL or CTL, however you want to pronounce that, to streamline the creation and management of clusters. And some of the use cases directly taken from one of the blog posts that was initially published. Obviously, when you are learning Kubernetes, you can learn the concepts without worrying about or wasting resources and stuff. In development phase, you want to test out some of the things, your controllers, how stuff will behave when you have certain number of nodes, replicas, and all that stuff. I actually have it running because it has bunch of things with this. Let me show that. So this is how you scale. So kubectl get nodes, not this one, but if I scale the replicas to maybe 100, it will start that. So it will see the counter. What I have done over here is I have also created a cluster with Prometheus. So there are certain integrations that you can also do with KWOK CTL. So I have done with Prometheus that you can just check from the documentation, but it will look something like this. So there is already Prometheus, and then you can run Docker Grafana, and then you can put that. So it will run for some time. It will then just go away. For some time, you'll be able to see all sorts of metrics which are there. So that's KWOK for you. And next is HPA. So HPA is pretty simple. It's horizontal pod autoscaler. What happens is whenever there is load that is coming in, you define HPA, and HPA will scale that. Three main components over there is control loop, metrics collection, and then it scales it. So based on the minimum and the maximum that you define. So controller, again, the control loop mechanism adjusts the replicas accordingly and takes metrics from the metrics Kubernetes API server. Some of the things that can be done over here is the issue here is that it can just scale up and down very frequently, creating a flapping experience. So, and it can do overscaling. So there are three main things that you can do is stabilizing window. So you can actually put a scale down stabilizing window that for this, once you scale down, then this is the stabilizing window that it should stay for that particular number. Then you also have scale down policies. So you can define some of the policies for scaling down in terms of the actual value for the pod or the percentage. So for example, you can see over there, you have pods that if you have this particular policy, maximum number can be downscaled over the period of 60 seconds is 4, or over the period of 60 seconds it's 10%. So whichever, if you apply this particular policy, whichever is lower will be taken over here, because if you have 100 then you have 10, but 10 is greater than 4, so 4 will be taken. But if you have 30, then 10% will be 3, So that will be the percentage that will be taken. So you can define these set of policies over there. Also, there is another thing which got introduced in Kubernetes 1.3.0, which was custom metrics. So you can also specify specific container low-level metrics, the top right over there. So container resource CPU, and you can give the target utilization for per container inside a particular pod where you want to do the scaling. Another auto-scaling mechanism in Kubernetes is VPA, vertical pod autoscaler. So pods often run with wrong resource. Like obviously the resource creating or defining resources, how much you need is a pain. Like no one gets it right for the first time, right? I mean, if you does, like you are pro, but no one usually gets it right. So sometimes it's too low, that leads to your OM kill stuff. Sometimes it's too high, like usually people waste a lot of resources. They just say, you need 512 mi or maybe 1 gigs of memory over there, CPU over there, and they just put the numbers, which leads to a lot of wastage. In VPA, there are three main things. One of the coolest thing is in-place resize. So the three things, VPA monitor pod usage and automatically adjust the size of that. Usually it will be when it does in auto mode, it will restart. But since Kubernetes 1.3.2, it can adjust the pod live, which is called in-place vertical pod autoscaling. That is something which is very cool. And off means recommendations. Now, just note down the off, because based on this, there is another tool that I'll be telling in the end kind of thing. So off will basically say that if it detects something, if there is VPA and stuff that you have set up already, VPA controller, it will tell you that you should do this. And auto means it will automatically do for you, but it will be a restart. And then in place will be something that adjusts the live running pod so that it has less number of drops of connections which is there. So with VPA, Kubernetes does the right sizing for you, and no more guesswork, no more wasted resources. Next hack is Kueue. So in Kubernetes, there is like not in Kubernetes, but there is this project called Kueue, which is a plugin manager. And what people have done, and Kubernetes is actually famous because of the extensibility ecosystem, the operator framework, that you create a lot of operators. And this is another thing which is called Kueue plugins. So with Kueue, there are more than like 300 currently 305 plugins that are distributed on Kueue, and you can install these set of plugins, and every plugin has a specific task that they achieve with that particular plugin. For example, I recently installed a CRD wizard. So we kind of use, like many of you, if you are using Kubernetes, you're familiar with K9s. People use K9s, and it gives you a nice TUI and gives you a lot of information about your Kubernetes cluster. So there's this person who created a CRD wizard as well, and they contributed to Kueue. They have also added this as an issue to K9 as a plugin. So I already have this running. So this is how it looks like, CRD wizard. So just do CRD wizard web. You can also view it on the web, and this is how it will look like. So you will have all the custom resources over here. You'll be able to see all the stuff. So this is something as a Kueue plugin that was installed. Similar to that, like there was in the slide, there are 305 plugins that you can choose from. I need to keep a track of time too. Next, device plugin. So in Kubernetes, there is a concept of device plugin. This has become even more important when we talk about these AI, ML, GPU, and different types of devices which are there. Traditionally, yes, Kubernetes was not meant for stateful workloads. Now it is. Kubernetes was not meant for GPU workloads. Now it is. So with every innovation that is coming in, with every wave that is coming in, there are new set of devices that you want your containers to kind of consume. So device plugins is the concept that lets you configure your cluster with support for the devices that require vendor specific setup. GPUs, NICs, FPGAs, or non-volatile main memory. In GPUs, you need a lot of things like just bare if you in the resource request section you just define I need a GPU, container won't get that particular GPU, a pod won't get that GPU. You need to do a lot on that GPU node itself. You need to have a specific runtime class for the Kubernetes to make it discoverable. You need to have runtime hooks. You need to have the device plugin, node labels. You need the specific drivers, the NVIDIA drivers to be installed. So although device plugins makes it possible, that it is possible, but it is a tedious task if you do it um, all by on your own. This is where you have NVIDIA GPU operator for which GPU Kubernetes device plugin. What it does is it automatically install all the stuff that you are seeing over here, the CUDA driver, the drivers, the runtime, the daemon set, the feature discovery. If you do kubectl get runtime class, you will actually see the NVIDIA runtime class over there that you can specify then in your pod manifest, and it will automatically then run. So this is the NVIDIA GPU operator that you install. It install like as a daemon set, it puts all the stuff, all the drivers, and makes your GPU ready to be consumed by a particular pod in this way. So you specify a pod and you specify in the resources for this particular thing, it's NVIDIA. So you specify that it wants nvidia.com/gpu1, means it needs one GPU. Now based on how you have defined it, in a way like is it sliced, is it a A100 that you have sliced into 7 slices and it is one corresponding to one slice, or is it a complete GPU? That's something that you define when you create that infrastructure setup. Next one is multi-tenancy hack. So many times what happens is, like few years back, if you go 5-6 years back, maybe the main problem was Kubernetes adoption itself. That's where you had services like GKE, EKS, all these coming in, simplifying all the experience, that okay, now you can go click here and you can select the number of nodes and you can boom create a Kubernetes cluster. Yeah, EKS you can go grab a coffee and come, and GKE you can still be okay, and there are some smaller cloud providers that we were talking about previously that takes even lesser time to create those clusters. But in the end, Kubernetes cluster creation became very easy with all the fancy managed services. The new problem that arose was this cluster per team, cluster per environment, and duplication of resources. Now in the enterprise, the issue is that there are too many Kubernetes clusters, and everyone, whenever they just join, they raise their hand, I just need a Kubernetes cluster for my own, just because I need it for testing, for whatever they need. They just raise a ticket or whatever, Jira, and they go over there. It goes to the platform team creates that, it comes back, it's a mess. And if you know, every Kubernetes cluster is a bare bone Kubernetes cluster unless it's part of the internal developer platform. There are policies, there are auto tools that gets installed to it. But in general, when you create GKE, it doesn't comes with the cert manager or ingress controller and stuff like that. You install that manually, and you install it for then all the clusters. So you have 100 clusters, you install 100 Argo CD instances, you install 100 Nginx controllers, you install 100 cert managers. So that's the duplication of resources, leading to cost and maintenance. So this is what is happening. Companies creating a lot of clusters. Yes, there is a solution called namespace. Everybody is familiar. kubectl create namespace. ContainerDays, it creates a namespace. ContainerDays 2, it creates a ContainerDays 2 namespace, which is fine when you have very limited number of teams. But when you talk about 100 teams, and every team wants their own set of namespaces, and every team wants their own set of controllers to be tested on those namespaces, things get messier, and it is not an automated process as well. This is where these are some of the limitations, like limited tenant isolation. Yeah, and also let's say one funky guy came and just blew up, created 3,000 secrets, so pressured up the etcd, and then the other in the room are having a problem. So that's a noisy neighbor problem. Because they won't be able to perform any task because etcd is already under pressure. So this is what noisy neighbor problem is there. Restricted tenant autonomy with respect to CRDs, because although a lot of resources are namespace scoped, but not all of resources are namespace scoped. One of the biggest ones is custom resources. They are all cluster scoped. That means everyone in the cluster will have access to the same custom resources. Next one is complex compliance requirements and operational and complexity cost, which we have already discussed. So this is where there is an open source tool called vCluster. So vCluster helps you create virtual Kubernetes clusters on top of Kubernetes. So that's how it looks like. So if you see on the left hand side, you had multiple Argo CD instances, you had multiple cert manager and multiple ingress controllers. Now what you can do is you can create one cluster in that, so that we call it as a host cluster. So one cluster which becomes your host cluster or base cluster, whatever you want to call it. So let's call it a host cluster for now. So you have this host cluster, and then now what you do is you have you install once Argo CD, Vault, Cert Manager, and Nginx controller, and then you share these for the virtual Kubernetes clusters that you create. Now, every virtual Kubernetes clusters comes with its own control plane. That's the beauty of it, because there will be no noisy neighbor problem. There will be no overload on the Kubernetes cluster itself, because if there are 10 teams, these 10 teams will have 10 virtual clusters. Every virtual cluster will have its own control plane pod running as a stateful set on the host cluster. And when they connect to that particular cluster, they will be able to do that using the specific kubeconfig file. Pretty simple. We'll just quickly see that in action, and then we'll move on to the next hack as well. kubectl. Okay, let me clear. The font size is good. Okay, we cluster create ContainerDays cd s25. So it starts to create a virtual cluster. Yeah, we just released 0.28, so I'm yet to update that. So it started creating a namespace because I didn't specify the namespace. So it auto appended vcluster to CDS25, and it has started creating. Meanwhile, it is getting created. What we'll do is we'll go here, kubectl get pods -a, and we'll be able to see that there is a new namespace and a new pod, which is a stateful set, which is the control plane component of this particular virtual cluster that is coming up. And soon it will be in running state. So it's initializing for now, and we'll not wait. We'll come back to this later on, and we'll move to next set of hacks. Next one is KYAML. How many of you have heard about KYAML? Okay, cool. So KYAML was introduced in 1.3.4, which is the latest Kubernetes version, as an alpha feature. So it's basically, you can say, best of both worlds kind of thing. So if you see on the left hand side, you have a YAML representation where no can means false, but in KYAML everything is explicit. So you specify that in string so that it's always explicit that this is what we want to say, rather than no just becomes false rather than a boolean. And also 11 can be read as number instead of time. So those are some of the things. KYAML rules are safer configurations. So no implicit types. White space, yeah, there is no white space stuff, because it uses, you can see in the second box, it uses curly braces for maps, and that for arrays and lists, and allow comments. These are allowed, like comments, trailing commas, all these are allowed already. What you can do today is you can actually see kubectl create deploy demo image demo, sorry, not demo, because it will then fail. So kubectl get deploy demo2 -o KYAML. So if you are on okay, it should have worked. kubectl version, yeah. So ideally it should give you the output. I'll also start the other playground, because here I know it works, but it takes time because this is a custom playground and that one was pre-built playground. So anyways, we'll wait for this as well. Meanwhile, let's go back and see what do we see here when we do kubectl. So interestingly, I didn't change anything, I didn't touch, and you saw me, I'm not a magician. Automatically, when I do now kubectl get pods -a, I just get one CoreDNS pod instead of all the other pods. What happened? The virtual cluster got created, a new kubeconfig file got created, it got added as a context to my existing kubeconfig file that was exported as the environment variable. This is what you give to your developers, to your different teams. And when they see it, they see only one pod, and they can do kubectl create namespace demo. They can do kubectl run nginx hyphen image nginx. They can do whatever they want, like create namespace, create pods, and all sorts of stuff. The low level resources are then synced by the syncer component. Okay, at least some of the demos are working, which is good. So KYAML is safer, so that's what it's okay. Why it didn't work? Now I know, because I have to export the kubectl underscore YAML as true. So, or maybe KYAML, right? Thanks for helping me. Appreciate that. And there you go. So you can, so it is 100% Kubernetes, like the YAML compatible. So there's no changes over there. You can get this output. You can also apply this. So you can write your own KYAML files, GitOps friendly, and everything works as it is intended to work. No white spacing issues and stuff like that. So this is what KYAML is about. And now we'll quickly move forward. Now all the demos work. So KYAML, yeah, this is what another subset of YAML, and keeps all the YAML perks and fewer white spaces and all that things. Next one is scheduling. So let's talk a bit about scheduling. So in Kubernetes, it's pretty simple concept. A pod comes in, user creates a pod like I did, kubectl run nginx. It goes to the scheduler picks the best fit node and it runs it. But the problem is when it comes to HPC, AI, ML workloads, things are not that easy. If you need 10 pods, that needs to be done like that. You need 10 pods. 10 GPUs for training, and you have availability of 4. So Kubernetes scheduler will schedule pod one by one, and it will leave rest of them. So your 4 GPUs are held up, but it's not even helping in training. So this concept is called gang scheduling. So you need gang scheduling, which is natively not supported by the regular Kubernetes scheduler. And this is where you have something which is called Volcano. So Volcano helps you in gang scheduling, like all pods in distributed job run together. It makes sure it happens. Dependency handling, worker pods wait for the master, and perfect for the MLAI workloads. Kueue is a newer one, more Kubernetes native, more for jobs oriented. It's not a scheduler replacement. It's for job queuing and enforces quotas and priority across teams. So this is the important concept over here. It's pretty easy, and it complements the default scheduler rather than replacing, which Volcano does. Another one, the next hack is the Kai scheduler. The stuff that I showed you when we were discussing about the GPUs and operators, and I specified NVIDIA, I need one. Kai scheduler actually helps you take fractional of that. Kai scheduler was open source by NVIDIA and at KubeCon, around KubeCon London, and it is kind of run AI open source implementation, you can call it. So you install NVIDIA GPU operator on your Kubernetes cluster, then you install Kai scheduler, and then you should be able to use scheduler as Kai scheduler. So you give the scheduler in your pod specification, and then give Kai scheduler, and you should be it will be able to understand 0.5, the fractional stuff that you need from the GPU. So you will be getting the time slicing, because that's what we need. Time slicing is a very important concept in Kubernetes, in the AI ML ecosystem, AI infrastructure. We cannot talk very deeply about it, but this is how it looks like. So NVIDIA GPU fraction, and the annotation you give GPU, you give 0.5, and Kai scheduler will be automatically able to understand that. Next one is ephemeral containers. So many people have used what is called distroless, distroless containers. They are good, they are slim, and they are easy, but they are a bit difficult to debug because they don't have any shell or anything in there. So there are containers. So these ephemeral containers are the containers to help debug the pods where there is no way to debug directly using the exec. So it attaches the container to the same pod and share a few namespaces, and it doesn't, you cannot define like readiness liveness probes, and resources also is disallowed in here. And this is how it looks like you can use kubectl debug if you have an nginx container, nginx, and then you can give image busybox. So it attaches that busybox container, and if you go inside, you will be able to see that the c group mntpid, they are the namespaces that get, so that you can debug it in a more easier way. Okay, I have 5 minutes left. That's a bit less on my timing that I had, but okay. Anyways, next one is reducing the pressure on etcd. So there are a lot of ways that you can do, like you can use limit ranger and resource quotas. First, obviously, if you reduce the pressure on API server, automatically it reduces the pressure on etcd. Clusterpedia is another open source project that can be used. Modify certain operations, like avoiding the agents to connect directly to the API servers, having strict policies in place for validation before it even goes to the next phase. etcd override server is another command that can be used, and some of the other things which we cannot go right now. Next one is Goldilocks. You remember the VPA, there was this configuration where you had no, and it just gives you recommendations. So VPA is vertical pod autoscaler, everyone with me, and it has something no, and then it has the in place, and then it has auto. So this one, what it does is, it's an open source project again, using Kubernetes VPA in recommendation mode. You see the suggestion of the resources in a neater way. AI, like we have to talk about AI as well, right? I talked some bits, but you can get a lot of information about your cluster, and you can troubleshoot your cluster. And this is one of the projects that is already they have submitted the application to CNCF Sandbox. This is Homes GPT, AI agent for troubleshooting the cloud native environments. So this is, you might have heard of K8 GPT as well. So it's in the similar lines. So you can have K8 GPT projects like K8 GPT, Homes GPT, that you can use to interact with your Kubernetes cluster in plain English, and it gives you good set of responses over there. PDBs for safer upgrades. So what happens when you do kubectl drain and you drain the nodes, automatic, or you upgrade your node? What happens is, automatically whatever is there on this particular node, it goes to other nodes, because in your specification you would have said 5 replicas, 6 replicas. So if replicas are less, controller will find something and it will start spinning up that on the other node. But some of your applications are critical, and when you do not do pod disruption budget, you do not specify the minimum availability for your application. So here in the PDBs, what you can do is you define the pod disruption budget, and you say minimum available to, that enforces the guarantee. Like it maybe you have 6 replicas. So what it will do is, minimum 2 is there. It will create a new node or move others to the new node. When it sees there are enough replicas which is matching or above then the min replicas, then it will start draining the other ones. It is helpful when there is node drains or upgrades which are happening, or voluntary disruptions. So recap, what did we discuss today? And you can count, they are 13. It was very difficult to, get these 13 in. So you had HPA, VPA, etcd. We talked about vCluster, KWOK, kubectl debug, YAML, KYAML, device plugin, Kai scheduler, Volcano, Kueue, Home CPD, Goldilocks, pod disruption budget. There is, I don't know if there is anything else. Yeah, these are the ones. Let's do a quick, there's one more which is not a hack, but it's a kind of a book that I and Daniel from Run Cates recently wrote on the ebook, which is free to download. So you can download for GPU enabled platforms. We have explained about the MIGs, time slicing, how to build AI platforms for teams, multi-tenancy, and all sorts of concepts over here. So you can download that for free as well. So with that, if you can tell me how many of you knew all 13 hacks, please don't raise the hands. At least I feel happy. At least there was one hack that everyone didn't know. Okay, now I won't ask. So I assume that it was helpful. Thank you so much for coming in huge numbers. What we'll do is we'll take a quick selfie if everyone doesn't mind. All right. Okay. Nothing is coming, but we'll try to do. Okay. Awesome. Thank you so much for coming. And
So let's start with, can VPA and HBA coexist for the same pod? Not prod, my gosh. How should the decision be taken?
yeah, so that's one of the thing. So you have to carefully use VPA and HPA for the same workload. The reason for that is there can be flapping issues and there can be conflicts where one says you want to resize and one says you want to go up. So again, custom metrics should be done for containers inside the HPA, and for the VPA it should be recommendation mode so that you can decide.
Thank you. Regarding vCluster, will many clusters not overload a host cluster etcd for tracking many vCluster and its resources?
No, because there is a concept. So I recently wrote a blog, complete blog on the performance as well. So what happens is you have etcd and everything for the host cluster, and then you have your separate stateful set, the separate control plane for your virtual clusters. But when people interact, everything is stored in that particular etcd, which is running inside the stateful set. So it doesn't overload your host etcd cluster, which is, I mean, if you have additional, like I can send you the blog that I wrote, it has even more details.
Thank you. Can vCluster be run on EKS?
It can run on any Kubernetes distribution.
Awesome. Very informative presentation. Thanks. Of course, I agree. Does KYAML also...
Thank you to the anonymous person. Big thank you. Shout out.
Does KYAML also support JSON?
Yeah, I mean, it's a mix. So hopefully it should. I haven't tried it, so should support. I don't know.
Saiyam, you're still around for a few minutes?
Yeah,
the lunch?
I'll be here.
You're still here, so if something
Yes.
pops up, people can find you around the spot.
From ContainerDays Hamburg, this video is proudly presented by Dux IT.